everyone. Welcome to my channel Decode Dynasty. In this video, we are going to learn about Wireshark Lab DHCP version 8.0. So, first of all, what is DHCP? DHCP stands for Dynamic Host Configuration Protocol. DHCP is a network management protocol. It is used on IP networks and automatically assigns an IP address to the devices to the network using a client server architecture. So let's begin with an experiment. Here is DHCP experiment. Let's begin with the step 1. So first of all, we have to open the command prompt. So here I have already opened the command prompt. The next is we have to type ipconfig/release. In the next step, we have to start up the Wireshark packet sniffer. So here I have opened the Wireshark. Now I have started the packet capturing. Now go back to the Windows command prompt and enter ipconfig/renew. Now again, we are going back to command prompt and typing ipconfig/renew. Wait for some time till the whole transaction is terminated. So here it is completed. Now the step 4 is wait until the ipconfig/renew has terminated. Then again enter the same command. So we are going to again enter the same command ipconfig/renew. So now this command is already terminated. The fifth step. When the second ipconfig/renew terminates, enter the command ipconfig/release. Again, we have to type ipconfig/release. Now, finally, enter ipconfig/renew. Now I have typed ipconfig/renew. Now, the step 7, stop Wireshark packet capture. Now here I am stopping the Wireshark packet capturing. We have completed all the 7 steps given in this experiment. This is the summary provided. First of all, we have done the ipconfig/release in the command prompt, then ipconfig/renew, again ipconfig/renew, and then ipconfig/release. And the last is ipconfig/renew. You can see here ipconfig/release. Here are all the data provided. Then ipconfig/renew. Here is IPv6 address. Everything is provided here. Subnet mask, default gateway. Now let's move towards the question and answers. First question. Are DHCP messages sent over UDP or TCP? First of all, for DHCP, we need to filter out. The filter is boot P. So we have applied the filter boot P, and here you can see all the DHCP messages. The first question is either whether it is UDP or TCP. So the answer is very clear. It is user datagram protocol, that is the UDP. Now the next question. In this question, draw a timing datagram illustrating the sequence of the first four packet discover, offer, request, acknowledge, DHCP exchange between the client and server. Also, for each packet, indicated the source and destination port numbers. Are the port numbers same as in the example given in this experiment? So let's move towards its answer. Here, for the graph, we need to go to the option statistics and then to the flow graph. You can see here the graph generated. We have already applied the filter, that's why only the filtered messages are shown here. Now we need to find the source and destination port numbers. Here are our discover, offer, request, and acknowledgement packet. For discover, the source and destination port numbers are 68 and 67 respectively. For DHCP offer message, the source and the destination ports are 67 and 68 respectively. For DHCP request, the source and port destination the source port and destination port are 68 and 67 respectively. For DHCP acknowledgement, the source port is 67 and the destination port is 68. Now, here it is asked whether the port numbers indicated in our Wireshark lab are the same as given above. So, in this document, we have already provided with the 67 and 68 ports which are used for DHCP. Hence, the answer is yes, they are same. Are the port numbers the same in the example given below? Yes, they are same. Now, next question. What is the link layer address of your host? For this, we have to go to the Ethernet. Here it is the Ethernet. And this is the IP address, which is 26 colon ED colon 49 colon 95 colon 52 colon CC. This is the source. And the destination is 60 colon E9 colon AA colon 53 colon 3B colon 27. This is nothing but the MAC address. The next question is, what values in the DHCP Discover message differentiate this message from the DHCP request message? So basically, DHCP Discover message is used by the client to find available servers, while the DHCP request message is sent by the client to request a specific IP address offered by a DHCP server. First of all, we will see the DHCP Discover message. And then the DHCP request message. In the request message, the option 54 DHCP server identifier is provided, whereas in DHCP Discover, there is no such column. So the difference is the DHCP server identifier. Moving towards the next question. Fifth question. What is the value of the transaction ID in each of the four DHCP messages? So we have to see the transaction ID. Here it is already covered. See, DHCP Discover transaction ID. This is the transaction ID in the hexadecimal form 0x8F09C656. Similarly, it is for offer, request, and for acknowledgement. The DHCP Discover, offer, request, acknowledgement. Four of the messages have the same transaction IDs. Now it is asked, what is the purpose of the transaction field? Also, what are the values of the transaction ID in the second set? Okay. So here it is the second set, that is the request and the acknowledgement. The transaction ID of this request and acknowledgement are same, which is 0x8DD1DB97. The purpose of the transaction ID field is to allow the host to differentiate which requests is being asked by the user. Now, sixth question. A host uses DHCP to obtain an IP address among other things, but a host's IP address is not confirmed until the end of the four message exchange. In the IP address, if the IP address is not set until the end of the four message exchange, then what values are used in the IP datagrams in the four message exchange? For each of the four DHCP messages, indicate the source and the destination IP addresses that are carried in the encapsulating IP datagram. So here we need to find the source and the destination IP address of each of the DHCP messages, which is discover, offer, request, and acknowledgement. Again, opening the Wireshark. This is the DHCP message. Here is our source address, which is 0.0.0.0, and the destination is 255.255.255.255. Then for the offer, the source IP address is 192.168.11.3, and the destination IP address is 192.168.11.168. For the DHCP request message, the source IP address is 0.0.0.0, and the destination IP address is 255.255.255.255. Now, DHCP acknowledgement message. For this, the source IP address is 192.168.11.3 and the destination IP is 192.168.11.168. Moving towards the next question. What is the IP address of your DHCP server? We need to find the IP address of our DHCP server. For this, we have to go to the DHCP request and then we have to find DHCP server identifier. So, this address which is 192.168.11.3. So, that was our IP address of our DHCP server. Eighth question. What is the IP address in the DHCP server offering to your host in the DHCP offer message? Opening the DHCP offer message. Here it is, the DHCP offer message. Then here you can see the option your client IP address. This is the answer of the question. 192.168.11.168. Ninth question. In the example screenshot in this assignment, there is no relay agent between the host and the DHCP server. What values in the trace indicate the absence of the relay agent? There is a relay agent in your experiment. If so, what is the IP address of the agent? So here we can see the relay agent IP address is 0.0.0.0, which means there is no relay agent. Hence, when the values of the trace indicate an absence of the relay agent since its IP address is 0.0.0.0. Now, 10th question. Explain the purpose of the router and the subnet mask lines in the DHCP offer message. So, the purpose of the router and the subnet mask lines in the DHCP offer is that the router lines indicates to the client which default router it should use to send messages, while the subnet mask lines instructs the client on which subnet it should use. 11th question. In this DHCP trace file noted in foot, the DHCP server offers its specific IP address. In the client's response to the first server offer message, does the client accept this IP address? Where is the client's response in the client's requested address? Going to the Wireshark, seeing the DHCP offer message, the IP address is accepted in from the clients towards the first offer message, which is given in the requested message. The client's response to the IP address is to accept the IP address 192.168.11.3 in the offer message due to the client requesting that specific IP address. Now, the next question. Explain the purpose of the lease time. How long is the lease time in your experiment? The lease time in DHCP determines how long a client is allowed to use the assigned IP address before it must renew the lease. Here you can see in the IP DHCP offer IP address lease time. The IP address lease time is 59 minutes and 59 seconds. Now, what is the purpose of the DHCP release message? The purpose of the DHCP release message is to release the IP address back to the DHCP server. The DHCP server issues and received acknowledgement of the client's DHCP request. Does the DHCP server issue an acknowledgement received of the client's DHCP request? What would happen if the client's DHCP release message is lost? So here we have to go to DHCP acknowledgement. Then we have to see for client MAC address. Here it is the client MAC address, which is cloud network underscore 53 colon 3b colon 27. And the address is 60 colon E9 colon AA colon 53 colon 3b colon 27. If the DHCP message get lost, then the client would send a release message, cancel its leave on the IP address, where the client would stop sending message back, meaning it acknowledges the message. However, the server cannot reassign the IP address until the lease from client is over with the particular IP address. The 14th question. Clear the boot P filter from your Wireshark window. Were any ARP packets sent or received during the DHCP packet exchange period? If so, explain the purpose of those ARP packets. So here I am clearing the filter boot P. So as you can see, there are numerous messages. Is there any ARP message? Yes, there is. See, 1, 2, 3, 4, 5, 6, and there are lots of ARP messages. So the answer is yes, there is ARP packet. So what is the purpose of it? The ARP is used to solve IP addresses to MAC addresses within a local network. We have already completed all the questions and here it ends the video. Thanks for watching.